In this limiting reactant problem, we will calculate the theoretical yield and the percent yield when 135 grams of aluminum react with 3.25 moles of oxygen gas in the equation given here to give 201 grams of product, aluminum oxide. We will approach this problem by calculating the maximum yield that we could obtain from each reagent separately. That means that we will have to do two separate stoichiometry calculations, starting in turn with each of the two reactants. Those calculations are done here. There's a lot of information on this page, but the top calculation involves taking the given mass of 135 grams of aluminum, first converting from grams to moles of aluminum using the molar mass of aluminum. The second conversion factor is a mole ratio that we obtain from the coefficients in the balanced equation that converts from moles of aluminum to moles of the product, aluminum oxide. And the last conversion factor is one using the molar mass of aluminum oxide to convert from moles of aluminum oxide to grams of aluminum oxide. The result of that calculation is 255 grams of Al2O3. The bottom calculation starts with the other reactant, the oxygen gas, and starts with a given quantity, 3.25 moles of O2, uses a mole ratio from the balanced equation that converts from 3 moles of O2 to 2 moles of aluminum oxide. And the last conversion factor involves the molar mass of aluminum oxide, same conversion factor that we used in the calculation above, to give us, as a result, the number of grams of Al2O3. And in this case, we get 221 grams of Al2O3. Now we need to decide which answer is correct. And it turns out that the smaller answer is always the correct answer. The larger amount could never form because the other reagent has run out. In this case, we have 255 grams from the calculation based on aluminum, only 221 grams of product based on the calculation starting with 2, and therefore the smaller amount is always correct. The correct answer in this case is in fact 221 grams of Al2O3. That is called the theoretical yield. And the other answer that we got, the 255 grams, is useless. It's meaningless. The last part of the calculation is to determine the percent yield. Now that we've calculated the theoretical yield in the first part, the theoretical yield again was 221 grams of Al2O3, we can calculate the percent yield from the equation given here, which says that we'll divide the actual yield by the theoretical yield and multiply that by 100 to get a percentage. Recall that the original problem told us that we got 201 grams of product. That's called the actual yield, and that's divided by 221 grams theoretical yield times 100 gives us a 91% yield of product for this reaction.